Welcome to everyone. In our previous lecture, we talked about the parallelogram law of vectors, and we derived the formula for the magnitude and magnitude of the resultant and the direction part. So the formula was that R is equal to under root of a square plus b square plus 2ab cos theta. This was if the two vectors are like the two sides of parallelogram. This is A, this is B, and draw this parallel A and parallel to B. You get the resultant part R, and the magnitude is the theta between the two vectors angle. This is the magnitude part R, and alpha is the angle that shows the direction part. So your magnitude part was R equal to a square plus b square plus 2ab cos theta, and tan alpha var equal to b sin theta divided by a plus b cos theta. So as we already discussed, that knowing the value of theta, that angle between the two vectors, and the value of two vectors, if the magnitude is given or if the vectors are given, then we have to calculate first their magnitude and substitute in this formula and the angle between the two vectors. We get the magnitude part, and then using this very formula we get the direction part. So these are the two generalized formulas to calculate the direction part and magnitude part of the resultant between the two vectors following the vector law of addition using parallelogram method. So now there can be numericals of different pattern. जो बच्चे अभी 11th में गए होंगे उनके लिए थोड़ी बेटर है कि पहले आसान आसान न्यूमेरिकल करें और बाद में थोड़ा डिफरेंट न्यूमेरिकल की तरफ जाएं. तो पहले ये ए वेक्टर है, फिर बी है, इसके अंदर थीटा है, आर कैलकुलेट कर सकते हैं और अल्फा कैलकुलेट कर सकते हैं. ये एक जनरलाइज्ड फॉर्मूला है और न्यूमेरिकल कैन बी ऑफ एनी टाइप. लेकिन लेट अस डिस्कस few special cases that if the vector 2 are, say suppose if two vectors are parallel, or if two vectors are mutually perpendicular, say it's A and this is B and this is A, this is B. If two vectors are ND parallel, then what will be the condition? So here theta will be 0 degree, here theta is 90 degree, and here theta is 180 degree. These three special cases can be calculated, and we can derive a generalized formula for the parallel vectors and anti-parallel vectors and the mutually perpendicular two vectors. So let us go one by one using this formula. First case first is if theta is equal to 0 degree. Whenever the angle between the two vectors is 0 degree, take it for granted that two vectors are moving parallel or they are moving in a straight same direction. Suppose when theta is 0, then A is moving along this direction and B is also moving along the same direction. There is no angle. Or you can say A is moving like this, B is moving like this, A, this is B. Or both the vectors are moving along the x-axis. If you take the 3, this I, this is J, this is K. A is moving along this, B is also moving along this, and theta is 0. So taking theta equal to 0 means the two vectors have the same direction. They can be parallel to one another. They can be like a collinear type, A and B. So here theta is equal to 0. Now using theta is equal to 0 in these two, we get a direction, magnitude part and direction part. So when theta is equal to 0, two vectors are parallel, then what will be the value of R? So R will be under root of a square plus b square plus 2ab cos of 0 degree, because you are taking theta 0. So you get R comes out to be equal to under root of a square plus b square plus 2ab, because cos of 0 degree is equal to 1. So you can write R equal to, you can use the formula a square plus b square plus 2ab equal to a plus b whole square. Square root gets cancelled. You get R is equal to a plus b. This indicates that if the two vectors are parallel or moving in the same direction, you can take their algebraic sum. There's no need of vector sum. Just for example, if you have a 3i and a 7i, just add them to 10i. Magnitude is 10. You can simply add them algebraically. So R is equal to A plus B means when the two vectors are parallel or in a same straight line moving either along the x-axis, or they can be both moving along the y-axis, or both they can be moving along the z-axis, or they can move in any direction. So simply you have to add them algebraically. There is no need to add them vectorially. Simply add them up, you will get the total resultant part. Now what about direction part? How you get the direction part when the theta is 0? So when theta is equal to 0, what will be the tan alpha? This tan alpha, it will be equal to, tan alpha will be equal to B sine 0 degree divided by A plus B cos 0 degree. And you know sine 0 is 0 and cos 0 is 1, and this is 0, you get B of 0 divided by A plus B, it becomes completely 0. So you have tan alpha is equal to 0. You can write it like tan alpha is equal to tan 0 degree, because tan 0 is 0. So tan cancels, alpha equal to 0. So this means if the A is moving along this direction and B is moving along the same direction, this is A, this is B, the R will be along the same direction. The resultant will be along the same direction. There is no variation of the result. One, adding up them algebraically gives the magnitude part, and the direction part will be along the same direction, along the direction A and along the direction B. Means if A is along the I and B is along I, your R will be along I. So the alpha, that is the angle that the resultant R made with one of the vector, that's equal to 0, means it moves along the A and B is also moving along the same direction, because the angle between A and B is 0. So you conclude here that the resultant can be added algebraically when the two vectors are moving in the same direction, and the direction of the resultant will be same as that of A and B. So this is the one of the case. Now moving towards the second case. So we have to do formulas, that is R equal, I can write it here, R is equal to under root of A square plus B square plus 2AB cos theta, and tan alpha comes out to be equal to B sine theta divided by A plus B cos theta. Now the case second, I may take that if theta is equal to, case second, if theta is equal to 90 degree, the angle between the two vectors is 90 degrees. Suppose A is moving in this direction and B is moving along this direction, and theta is 90 degree. What will happen at that very time? So here theta is 90 degree. So substitute here theta 90, you will get the R part, and substitute here theta 90, in that two very cases you get the direction part. What is the direction of the resultant? So first R for theta 90 will comes out to be equal to under root of A square plus B square 2AB cos 90 degree, and you know cos 90 degree is equal to 0, so you get R is equal to under root of A square plus B square, it's going to be 0, it's plus 0, so you get R is equal to under root of A square plus B square. Well, simply you see, if vector A is along this direction and vector B is along this direction, this will be R. Say if I draw the parallel here is R. If I draw parallel B, so this is A. You can use simply Pythagoras theorem, because theta is 90 degree between A and B. You use simply Pythagoras theorem. A square plus B square is equal to R square. So R is equal to under root of A square plus B square. So take it that when the angle between the two vectors is 90 degree, just follow up the Pythagoras theorem. Pythagoras law, that the perpendicular square plus base square gives the hypotenuse square. It's like this. It's a vector 1, this 3i, this vector b, say 3j, you get 3 square plus 3 square, and under root of these two, the base square, you get the hypotenuse plus perpendicular square, you will get the resultant part, the magnitude of resultant part. So when the two vectors were parallel, the theta was 0, you can add them simply. When two vectors are mutually perpendicular, then you can use the Pythagoras theorem to calculate the resultant part, to calculate the hypotenuse. The hypotenuse behaves as a resultant here. So this base square plus perpendicular gives r square. So for any two vectors, when they are mutually perpendicular, take for granted that their resultant will be calculated using Pythagoras theorem, and result is behaving as a hypotenuse part of that very triangle. This is the resultant part, that is a square plus b square. This also simple form to calculate the resultant part. Now what about this very part, that's direction part. So now to calculate the direction part, for the case when theta is 90 degree, when theta is 90 degree, what will be the value of alpha? So this is a vector A, and this is a vector B, and it was actually like this, B, and I draw the perpendicular, this is R, this is a 90 degree here between A and B angle. What you can write, this is A, this is B, they are mutually perpendicular. So what would be the R? The alpha. So the tan alpha will be equal to, this is B sine 90, that is B sine 90 degree divided by A plus B cos 90 degree. And you know sine 90 degree is 1 and cos 90 degree is equal to 0. When you substitute, you get alpha comes out to be B into 1 divided by A plus B into 0. This part becomes 0. You get B divided by A. So the tan alpha, you get alpha, it's tan alpha actually. So tan alpha will be equal to, so tan alpha will be equal to B by A. You can easily take, as I said, these are the mutually perpendicular two vectors. You can simply write perpendicular but a base gives this angle tan. You can calculate easily. Tan alpha is equal to perpendicular upon base. So this is the how to find the direction part. When theta is 90 degree, magnitude can be calculated either simply by applying Pythagoras theorem, and the direction part simply is perpendicular but a base. If this is j, it says I, j, the value before the coefficient of j divided by the coefficient of I. So if it's here, one vector is 3i, 2j, it's 2 by 3, gives you the tan alpha direction part. This is how we calculate the direction part when theta is 90 degree. Simply b divided by a. So direction part alpha is equal to b divided by a, or you can sometimes write it alpha is equal to tan inverse of b by a. So this is another way. Now the third case, when the third case we are talking about, if theta is a special case third, if theta is equal to 180 degree, means two vectors are anti-parallel. A is moving along this direction, B is moving along this direction. See this origin. A is along this direction, B is along this direction. You know R is equal to under root of A square plus B square plus 2AB cos theta and tan alpha is equal to b sine theta divided by a plus b cos theta. Here the two vectors are opposite vectors. They have an angle 180 degree. How the angle affects the magnitude magnitude of the resultant part. So taking first in consideration, r comes out to be equal to under root of a square plus b square plus 2ab into cos of 180 degree. So you get r is equal to under root of a square plus b square plus 2ab. Cos 180 degree is minus 1. So r is equal to, right, cos 180 degree is equal to minus 1. Right, under root of a square plus b square minus 2ab. You get easily the formula a square plus b square minus 2ab. You will get r is equal to under root of a minus b whole square. Because you know a square plus b square minus 2ab is equal to a minus b whole square. That is what I did here. Square root cancel. So r comes out to be a minus b. Simply, when theta was 0, you just add them algebraically. Now, if theta is 180 degree, subtract them algebraically. If it is 5 Newton, it is 3 Newton. If suppose a vector of value 5 Newton is moving along this direction A and B is moving along this direction, take their minus 5 minus 3, give the R. So when the two vectors are oppositely moving, you can directly subtract them and you can get the value of the resultant part. And what will be the direction part? That varies, that depends upon the magnitude of A and magnitude of B. So the third case indicates that when the two vectors are oppositely moving, you can take their sum by subtracting them. And when the two vectors are mutually perpendicular, you use the Pythagoras theorem. And when two vectors are parallel, are moving in the same direction, then you take the resultant along the direction where the vectors are moving. So let's now discuss it further. Now, what about the tan alpha? So now tan alpha comes out to be equal to b, that is sine of 180 degree, divided by a plus b cos of 180 degree. B into 0, because sine 180 degree will be equal to 0, divided by a plus b cos 180 is minus 1. But this 0 make it whole 0. So your tan alpha can be equal to 0. Here we can take a tan alpha as 0, and sometimes we can take tan alpha as 180 degree also. Tan alpha is equal to tan 180 degree. Tan cancel, alpha is equal to 180 degree. Now what does actually this mean? Here how we take the direction part. Here the situation is different. When two vectors are moving opposite to one another, it is A and this is B. At that very time, what will be the value of R and what will be the direction of R? Since we know when two vectors are moving opposite direction, and angle is 180 degree, at that very value R is equal to A minus B. You get it. Now, what will be the direction of R? What will be the direction of alpha? I took it as 0 and I took it 180 degree as well. Now, try to understand in a different way. If A is greater than B, and if A is greater than B, then R will be moving along this direction. And if B is greater than A, then R will be moving along this direction. So R can have the different value. R can have a different direction here. If I take the 0 degree, if A is greater than B, then R is along the 0 degree. But if B is greater than A, with respect to this line, then it's 180 degree, R is moving along this direction. Simply, we can understand is, if a force of 5 Newton is along this direction and force of 7 Newton is along this, obviously, object will move along this direction with the resultant 7n minus 5n is equal to 2n. 2n is the magnitude part, this A minus B. and the direction will be along this direction, that is along the 7n, because 7 is a greater value. If the vector is along the 10 Newton, another vector is moving along the 3 Newton, then the resultant object, it's a ball, is applied by a force of 10 Newton in this direction, and the same ball is applied by the force, the 3 Newton along this direction. Obviously, ball will move along this direction with the magnitude is 10 minus 3, that is 7 Newton, and it will move along the direction of 10. If it is along I, then it will be 10I. So I will make it more simpler like this. If you have A and you have a vector B, say if this is along I, then this is along minus I. R will be, if A is greater than B, then R will be along positive I. And if A is less than B, then R will be along minus I. So यहाँ पे direction of R, if B is greater than A, it will be along R this. If A is greater than B, then R will be along this direction. So depending upon the magnitude of the one of the vector, the direction of the resultant can be taken accordingly. But if A and B are same, suppose if A vector and B vector is same, of same magnitude, condition is if A is equal to B, then the object will not move, it will sit here. So A minus B will equal to the 0 vector. They call it null vector, that we already discussed it. So these are the three cases that we discussed today, and these are three special cases. But sometimes there can be a different value of R. So R is equal to under root of A square plus B square plus 2AB cos theta, and tan alpha is equal to B sin theta divided by A plus B cos theta. You can now play it differently, knowing the value of theta and knowing the value of A and B. Sometimes you are given R, sometimes you are given A, B, calculate cos theta, calculate the angle. Sometimes their magnitude is equal. And there are so many patterns of numericals that you can go along, go through the books, and then go through many numericals. You will understand easily. Suppose if I take the one example, find the angle between the two vectors, find theta between the two vectors if the two vectors are of equal magnitude and the resultant is equal to either of the vector. The question is कि दोनों वेक्टर बराबर है आपस में, दोनों का मैग्नीट्यूड सेम है, आपको एंगल बताना कितना है। अगर दोनों वेक्टर्स का मैग्नीट्यूड सेम है और जो रिजल्टेंट है वो इन दो वेक्टर्स में एक के बराबर है, तो आप हमें बता दीजिए एंगल कितना होगा। क्वेश्चन इज इन द टू वेक्टर्स of same magnitude, find the angle between the two vectors of equal magnitude, and if the resultant of the one of the vector, if the resultant is equal to magnitude of the either vector, then calculate the theta. फिर से मैं रिपीट कर रहा हूँ क्वेश्चन कि हमें ये बताना है एंगल बिटवीन द टू वेक्टर्स कितना होगा। B है, A है, व्हाट विल बी द वैल्यू ऑफ थीटा अगर A B के बराबर है और दो में से रिजल्टेंट जो है दो में से एक के बराबर, या ए के बराबर है या बी के बराबर है। कंडीशन है ए इक्वल टू बी और रिजल्टेंट जो है वो या ए के बराबर है और या बी के बराबर है, आपको थीटा दिखाना है। तो इसका सिंपल मतलब है कि आपका ए बी के बराबर है और अगर ए बी के बराबर है, बी आर के बराबर है, तो ये तीनों आर आपस में बराबर है। तो सोल्यूशन कैसे होगा, योर ए इज इक्वल टू बी इज इक्वल टू आर। सपोज हम इसका रखेंगे बराबर एक्स के, क्योंकि हम खुद ही कह रहे हैं टू इक्वल वेक्टर्स ऑफ इक्वल मैग्नीट्यूड and the resultant is equal to the magnitude of either of the vector. That means a is equal to b, b is equal to r, तीनों को हमने x के बराबर रखा। then calculate the angle, हमें cos थीटा डिटरमाइन करना है। तो मैं यहाँ फॉर्मूला लिखूंगा, using formula this one I can write r is equal to under root of a square plus b square plus 2ab cos theta, स्क्वायर यहाँ आ जाएगा, r square is equal to a square plus b square plus 2ab cos थीटा। यू नो आर भी x के बराबर है, ए भी x के बराबर है, बी भी x के बराबर है। एक्स स्क्वायर इज इक्वल टू ए के बदले एक्स स्क्वायर प्लस बी के बदले एक्स स्क्वायर, 2 इंटू ए के बदले एक्स, बी के बदले एक्स स्क्वायर cos थीटा। ऑब्वियसली ये x कैंसिल हो जाएगा, ये x यहाँ आ जाएगा, माइनस एक्स स्क्वायर इज इक्वल टू 2x स्क्वायर cos थीटा। So you will get x square cancel. You get cos theta is equal to minus. You get 2 cos theta is equal to minus 1. You get cos theta is equal to minus 1 by 2. And cos theta minus 1 by 2 के बराबर तब होता है जब cos 120 डिग्री होगा। cos theta cos 120 डिग्री माइनस 1 बाई 2 के बराबर होता है, तो cos cos कैंसिल, थीटा इज इक्वल टू 120 डिग्री। इसका मतलब है कि जो दो वेक्टर है इनका एंगल ऑब्ट्यूज होना चाहिए ग्रेटर देन 120, ग्रेटर देन 90 लाइक दिस। तो यहाँ पे 120 डिग्री एंगल। अगर ए बी के बराबर है यानी इनका मैग्नीट्यूड सेम है और एंगल 120 डिग्री है, तब जो रिजल्टेंट निकलेगा दैट विल बी, वो या तो ए के बराबर होगा या तो बी के बराबर होगा। ये एक आपको क्राइटेरिया कंडीशन मिली कि एट 120 डिग्री एंगल, व्हेन एंगल बिटवीन द टू वेक्टर्स इज 120 डिग्री एंड द मैग्नीट्यूड ऑफ द टू वेक्टर्स इज सेम, एट दैट वेरी टाइम टेक इट फॉर ग्रांटेड दैट द रिजल्टेंट इज इक्वल टू ईदर ऑफ द वेक्टर। तो ये कंडीशन है फॉर द वेक्टर्स ऑफ इक्वल मैग्नीट्यूड एंड द रिजल्टेंट इज सेम एज दैट ऑफ द वन ऑफ द वेक्टर। तो ये इस तरह के बहुत सारे न्यूमेरिकल्स हैं जिन्हें आप सॉल्व कर सकते हैं। इसके बाद हम जाते हैं पॉलीगॉन लॉ ऑफ वेक्टर्स पे और एसोसिएटिव प्रॉपर्टी और कुछ और प्रॉपर्टीज हैं, वो हम नेक्स्ट लेक्चर में देंगे। थैंक यू वेरी मच।